Hi students, today we're doing chapter 7, section 3. Chemical energy. Chemical energy is the energy stored in the chemical bonds of a substance, so inside the bonds. Chemical bonds. Breaking bonds, when you break bonds, it requires energy. And when you form bonds, it releases energy. The energy is usually released in the form of heat and light. Chemical energy. Heat exchange during reactions. An exothermic reaction releases heat, so it gives off heat. An example would be lighting a match. When you light a match, around it gets warmer because you are releasing heat. The energy released as the products form is greater than the energy required to break the bonds in the reactants. So you're releasing more energy when products form than is needed to break the bonds of the reactants. And an example of this would be a combustion reaction of methane, and heat is always written as a product. So it's written as a product when it is an exothermic reaction. This also shows exothermic. When you have an exothermic reaction, you're in this diagram below, as the reaction is going, the energy required to break the bonds up here, and then as the reaction goes, you're releasing energy, and so the amount of energy being released is this much. That is an exothermic reaction. In an endothermic reaction is the exact opposite. It's absorbing heat, so it gets colder. The energy required to break the bonds of the reactants is greater than the energy released as the products form. So this is a picture of an endothermic reaction. The reactants start out here, and then the products are higher. So it takes the energy required to break these bonds is more than what's being released. Not much energy is being released. And that is how much energy needs to be absorbed. Here's an example. When potassium chlorate decomposes, it absorbs heat, and when it breaks up. And it does get colder even though it's absorbing heat, because it's taking heat away from the surroundings, so then therefore the surroundings get colder. That is it for today's note.